Alrighty, guys, let's get into this one. Still talking about those arithmetic sequences. This time we're going to focus on the other type of arithmetic sequences, the recursive arithmetic sequence. Here's our learning objective for today. I can write a recursive formula given a sequence. So arithmetic sequences, it's just a list of numbers that follows a pattern. And for arithmetic, that pattern is either adding or subtracting. That number we're adding or subtracting by every time is known as that common difference. So here's an example, 3, 5, 7, 9. We're going up 2 every time. So my common difference for this one is just 2. Here's a couple more examples, just a quick review. Let's answer these ones, guys. Looking at what we have here, 7, 10, 13, 16, 19, 22. What's my common difference? Plus 3 every time. For the next one, 3, 6, 12, 24, 48. What's my common difference? This time there isn't one. This has a different pattern. You're actually doubling every time. This would be geometric times 2. The next one, 99, 88, 77, 66, 55. You could probably see the pattern, but what's really going on? This has a common difference of minus 11, negative 11. So just quick review. Is the following arithmetic? If it is, describe the pattern. You have 5, 10, 20, 40. What's the pattern? What's going on every time? In this case, it's timesing by 2 again, so it's not arithmetic. Look at this next one, 5, 8, 11, 14. What's really going on? We're adding 3 every time, so this is arithmetic with a common difference of 3. Bottom one here, 25, negative 10, negative 25. Arithmetic again, because we're subtracting 15 every time. So our common difference is negative 15. Now for the recursive part of this. When we had explicit arithmetic formula, that allowed you to plug values in and find any value of any term in your sequence. Recursive is a little opposite. This formula basically just states what is going on with the sequence. It starts with the first term and whatever that first term equals, and then it starts with an equals the previous term, and then it goes on from there. An is our general rule. It's like the pattern that's going on. So given this recursive formula, find the first 4 terms. If you have the first term is equal to 20, and then our rule is the previous term plus 6, find the first 4 terms. All this is telling you guys, all recursive is telling you is what the first number of our list is, and then what to do to get to the next number. The way I like to think of it is that the explicit formula jumps you to any term you want, where recursive formula does it one step at a time. So it's like these are stairs, where the explicit formula is like an elevator. It'll just take you to wherever you want to go. So looking for the first 4 terms here, you have 20, and then you're adding 6 every time. So it'll be 20, then 26, then 26 plus 6, 32, then 32 plus 6, 38. First 4 terms. Given this formula, find the first 4 terms. So same thing again. This time, first term is negative 18, and our general rule is the previous minus 3. So coming up with the first 4 terms, my first one is negative 18, it tells us, and then I'm subtracting 3 every time. Negative 18 minus 3, negative 21. Negative 21 minus 3, negative 24. Negative 24 minus 3, negative 27. And the sequence will just continue on with that pattern from there. Recursively makes it very easy for you to tell what's going on with the pattern. Next, write a recursive formula for each sequence. So here's our list of numbers. Here's our sequence. Recursive formula always has the 2 parts. We have to say what the first term is. We have to say what the general rule is. What's the pattern? So let's use our recursive rule and fill in what we know. We know what the first term is. It tells us in the list. It's 7. So 7 equals A1. Now we need to come up with a general rule. To write that, we have our any term equals the previous term plus or minus the common difference. So looking at this, what is our common difference? I went from 7 to 10 to 13 to 16. Hopefully you're noticing it's adding 3 every time. So my recursive rule is just this right here. A1 equals 7, AN equals AN minus 1 plus 3. Let's do it again. This time we have 3, 9, 15, 21. Remember our recursive rule. We need A1 and what it equals, and we need the pattern next to our AN minus 1. So we have 3, which is our first term. Then I go from 3, 9, 15, 21. What am I adding every time? I'm adding 6 every time. So my recursive rule, A1 equals 3, AN equals AN minus 1 plus 6. Ooh, I got a third one here for you. 97, 87, 77, 67. Write the recursive rule for it. First term, 97. What's happening every time? I'm subtracting 10 every time. So I go AN equals AN minus 1 minus 10. And that's all I got for you guys. Let me know if you have any questions.